Hey guys, today we are going to do 5-2, polynomials, linear factors, and zeros. So I will be able to analyze the factored form of a polynomial, and I will be able to write a polynomial function from its zeros. The big idea, finding the zeros of a polynomial function will help you factor the polynomial, graph the function, and solve the related polynomial equation. So 1, we are going to write a polynomial in factored form. So first we're going to take out our GCF, and we will have and I can factor that inside what two numbers multiply to -15 and add to -2, -5 and 3. So I have x times x minus 5 times x plus 3. If we were to check, we could multiply this out and we would be left with what we started with. So some key concepts for roots, zeros, and x-intercepts. The following equivalent statements about a real number b and a polynomial p of x is equal to a sub n, x to the n, and so on. X minus b is a linear factor of the polynomial function p of x. B is a zero of the polynomial function y is equal to p of x. B is a root or solution of the polynomial equation p of x is equal to 0. And b is an x-intercept of the graph y is equal to p of x. So these are just clarifying all of the vocabulary and terms we've already known. So in order to find zeros of a polynomial, we are first going to use the zero products property to find our zeros. So I take each set of parentheses and set them equal to 0. So x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. X equals -2, x equals 1, and x equals 3. I'm going to graph those because we know where they are going to be on our graph on the x-axis. I then want to find points of x values between our zeros to evaluate y, so we know where our y values are. So in between -2 and 1, I can pick -1. So y is equal to -1 plus 2 times -1 minus 1 times -1 minus 3. So I get 1 times -2 times -4. And we get my y value is equal to 8. So I have a point -1, 8. We are going to find our y-intercept as well. So if I plug in 0, I get y is equal to 2 times -1 times -3, which is 6. Then I need to plug in a value between 1 and 3. So I'm going to plug in 2. Y is equal to 2 plus 2 times 2 minus 1 times 2 minus 3, which is equal to 4 times 1 times -1, which is equal to -4. I want to determine my end behavior. So if I was to multiply this out, I would get x cubed as my first term therefore making it odd, positive, so it will be down, then up. So if we put this all together, no, my end behavior is like that. And my graph will look something like that. So the factor theorem describes the relationship between the linear factors of a polynomial and the zeros of a polynomial. So if the expression x minus a is a factor of a polynomial, if and only if the value a is a zero of the related polynomial function. What is a cubic polynomial function in standard form with the zeros -2, 2, and 3? So I know that my factors are x minus a, and if these are my a values, I have -2, 2, and 3. I have x minus -2 times x minus 2 times x minus 3. So I have x plus 2 times x minus 2 times x minus 3. If you multiply that out, you get the standard form of x cubed minus 3x squared minus 4x plus 12. We now want to write the quartic polynomial function in standard form with zeros -2, 2, and 3. So once again, I'm going to do x minus -2, x minus -2, x plus x minus 2, and x minus 3. So I have x plus 2 and the standard form of that is x to the 4th minus x to the 3rd minus 10x squared plus 4x plus 24. Is the function. And if we graph both of these functions, we want to see how the graphs are different. This first graph was A, and the second graph was B. Both graphs have x-intercepts at -2, 2, and 3. The cubic has down and up behavior. The quartic has up and behavior. So here we would be going down and up. Here we would be going up for both. And the cubic function has 2 turning points and crosses the x-axis at -2. The quartic function touches the x-axis at -2 but does not cross it. So here we touched and went back up. And we have 3 turning points. 1, 2, 3. The reason we touch and come back up is because we have a multiple 0. And we had in our factored form x plus 2 squared times x minus 2 times x minus 3. So we had a repeated linear factor of x plus 2, making -2 a multiple 0. So, in particular, the x plus 2 factor appears twice. We can say that -2 is a 0 of multiplicity 2. In general, a is a 0 of multiplicity n means x minus a appears n times as a factor. So here we had -2 is a 0 with multiplicity 2. So if a is a zero of multiplicity n in the polynomial function y is equal to p of x, then the behavior of the graph at the x-intercept a will be close to linear if n is equal to 1, close to quadratic if n is equal to 2, close to cubic if n is equal to 3, and so on. If we need to find the multiplicity of a zero, what are the zeros of f of x is equal to x to the fourth minus 2x cubed minus 8x squared? What are their multiplicities? How does the graph behave at these zeros? So, I'm going to factor this. X to the fourth minus 2x cubed minus 8x squared. Going to take out my GCF first, which is x squared times x squared minus 2x minus 8. What multiplies to negative 8 and adds to negative 2? X minus 4, x plus 2. And since we have x squared, x is equal to 0, so the number 0 is a zero of multiplicity 2. The numbers x is equal to negative 2 and x is equal to 4 are zeros of multiplicity 1 because they occur once. If we're looking at a graph, we could have a relative maximum or minimum point, and a relative maximum is the value of a function at an up to down turning point. So when we were going up to down, right here would be our relative maximum, and opposite for relative minimum, we would be going from a down to up turning point to have a relative minimum. We can do these by using our graphing calculators. So if you plug in the function given, we could then use the maximum or minimum function on our calculator to find the x values of where we have our relative maximum or minimum. You guys go ahead and try these on your own.